Hi, my name is Ignatius and I'll be taking you through a short summary of Stata statistical software. By the end of the summary video, you'll be able to navigate the Stata interface, perform data management, as well as some statistical tests to gain more insight on the patterns and structures underlying in your data. You'll also be able to fit some basic statistical models such as the OLS regression model. So we begin by exploring the Stata interface, whereby on our left we have the command or the review window, which lists the command which you execute in Stata. We have the output window, which is on the top middle part, shows the outputs that will be displayed after running certain commands, which brings us to the command window, whereby here is where we write our commands and press enter to execute them, and we send the results to the output window above. On the far right or top right, we have the variables window, which displays variables within the dataset in the working memory. The properties window displays properties about a specific variables under the variable first half of the window, while the data section displays characteristics of the whole dataset in the working memory. The menu bar has statistical options also, which you may use alternatively when you don't want to use the command window. So you may use Stata in two ways, using the command window or through the menu interface and following certain prompts to arrive to what you need to do. For example, creating a histogram or a time series graph as well. You can do that by using the menu or using the command window as well. The only disadvantage about Stata is that it's proprietary, so every update requires an updated license file, which you will be charged for. So I will proceed to open a do file containing the entire lesson 1 to 4 that we explored with the narco analytics, advanced programming, the first cohort. And this just describes the commands that we went through. So the first command is clear, which clears the working memory. So right now we don't have anything in our working memory, as is evidenced by there are no items to show message in the variables window, as well as no information in the properties window as well. So the command cd changes the working directory, points Stata to where the files you want to work with are stored. Stata does not include them in its own memory, it just points them to where they are sitting, so that when we want to utilize them, we can load them into the working memory, and when we are through, we can discard them. This makes Stata faster than most of the other statistical softwares. You can use datasets from online repositories by specifying the URL after the use command as follows. We can see the dataset loaded, and we can view the variables within from the variables window. Selecting a specific variable will display its characteristics under the variables window in real time. So the list command will list individuals if it's specified alone. So on the output window, the more message that you see there, it allows you to view a limited amount of output. If you want to view more output, click more letters or any letter on your keyboard apart from Q. If you don't want to see every observation, click Q to break the printing of the output. In our case, we had 200 observations. You'll have to click until you've reached the last observation or the output for the last observation is printed out. If you want to view or rather narrow down your output to certain variables, just add them as a list after the command. You can abbreviate commands in Stata as well. So we can see information for the two columns across all individuals. For the first 5 observation, we use an in qualifier so that we see the same information but only for the first 5 individuals. Specifying a negative on the starting number starts counting from the last position or from the bottom of your dataset or the last end of the dataset. In this case, it will count from the third last observation through to the last observation, which is denoted by L. So we can see the last 3 observations printed out. We can list values on measurements that we want that meet certain criteria by using the if qualifier. And we see only measurements for the individuals whose math score was greater than 70. So those are some basic functions to get around your data in Stata software. So the H command loads the help wizard, which gives more information about a certain command. So you specify the command after the H or help command, okay? And you can proceed to view what the command that you're looking for assistant on does and additional options that you can use to manipulate its behavior. To comment out codes you don't need, in one line add an asterisk. For multi-line comments, you can use a slash followed by asterisk and end that particular multi-line comment with the inverse of these symbols. So you can also open the data editor by using the command browse or by clicking the icon with the magnifying glass, the table icon with the magnifying glass. If you want to change values in your data, you can open the data editor in edit mode by clicking the table icon with the pencil on it. The script with the pencil on it opens the do file editor, and a do file, which is what I've opened, contains already written code for generalization or replication purposes, so that if you can share your code with a colleague, it will be easier for them to interpret or just reproduce your analysis and understand your results. It's important when a study is trying to be justified as well. So proceeding on, this do file consists of code across the entire Stata program. So when you get this do file and run it, you will be able to see all the areas we covered across the week. The codebook command just summarizes information about variables. So for each variables, it gives some statistics or descriptives about it. It gives us the type of the variable, the range, that's the minimum and maximum value in that particular variable, and the unique values, as well as the frequency if it's a categorical, as we can see, the frequency of both categories, which units are missing and which ones are unique as well. Summarize provides summary statistics. The tabulate command provides summaries on the variables that you pick. For example, the frequency of each occurrence of, for example, a categorical variable such as socioeconomic status gives us the frequencies of occurrences across the three levels and their percentage proportion and their cumulative percentage. So the tabulate command only offers those descriptives, while the summarize offers, in addition to those, mean and median, or rather central tendencies. For visuals in Stata, we draw a histogram using the hist command. So if you want to specify more options, we can specify the normal option to add a line which checks if it's a normal distribution, and we can adjust the width of our interval to better describe the relationship of or the distribution of our variable. For the box plot, that is the syntax, and you specify one variable or a variable list to plot multiple box plots for your list of the variables. So the graph box part is the one you need in order to achieve a box plot in Stata. For a scatter plot, you use the command scatter. So just to demonstrate, let's visualize a histogram. So remember that you must comment not in the same line as commands. So just checking a histogram, that's how it looks like in Stata. You can adjust or the size of the interval there, the x-axis, and also add a line to gain insight into your data. By specifying these options, we can see clearly that our writing scores are normally distributed just by changing or including the option of the normal to include or impose a line over our histogram. So basically we can see it is slightly skewed to the right in this case because it hasn't attained the bell shape accurately. So we can generate or create new variables to store different values using the gen command, which is short for generate. And in this case, we were generating a count variable to store all the non-missing values of the socioeconomic status. So it should assume a value of 1. And we want to construct a bar graph which is useful in showing the frequencies of different categories on a categorical variable. So if you need different metrics on one plot, you can use the Twoway command to display two metrics or two plots in one frame. So you just wrap all the plots within parentheses and then specify a different scatter plot for each of your condition. In this case, we want a scatter plot for the males to be colored in blue and the scatter plot for females to be colored in red. So the points for females and males across these variables will be identified by the colors, but they are going to be compared on one scale. So we can also generate variables to store values derived from computation from other variables. So here we are storing the scores across, or the sum of scores of the math, science, and social studies subjects into the variable total, and we can summarize the same to view statistics on it. So the replace command is used to change the values of already increasing or already existing, rather not increasing, variables. So we want to replace the missing values which will be encountered in the total variable that we just generated with the maths and the social studies test scores added if the science score in our computation of total is found to be missing. So we can replace the missing values with the sum of the maths and social studies scores. So to use Stata datasets that are inbuilt and are stored on the web, we can use the web use command. In this case, we are using the auto dataset. To view a directory of inbuilt datasets, we can type the command system use and dir to check the directory. So these are the datasets that come standard with Stata. So to check your current directory, use the command pwd. And if you want to see the Stata files which are inside of your directory, you can specify that by saying show me all the files that end in the file extension .dta, and you can also view all the do files as well. This is important when you don't know the file you are using and there are many files located in your directory. Hence, you can filter them out like this, and when you're ready to use the dataset, you can load it into the working memory by typing the use command. And if it's a do file you're trying to executing, you use the command do and specify the name of your do file. In this case, that one for example. Not For us not to lose progress, we are not going to explore on that. So in addition to modifying the variables in this way, we can also sort our variables. We were just experiencing how to view the current working directory, how to view inbuilt datasets using the sysuse command, and how to load them in using the web use, because data is proprietary and they are stored in their repository, okay? By proprietary, you must pay for the license. So using the command sort is going to sort in ascending order by default any variable you list after it. And in this case, you can also generate a variable which will store the numbers of all the indexes of our observations. This section leads us to viewing outliers and treating them. In this case, we use the auto dataset, and we sorted the price column, which is one way of identifying outliers. So by sorting that column, you can see if the maximum value, which is at the bottom, we said it sorts by ascending in default. So we can see if this value is very far from the next second last value and determine if it's an outlier or not, as well as on the other end, if it's lower than the second most or the second observation. If it's too much lower, you can conclude that it's an outlier. So that's one way of identifying outliers, by sorting them. So this variable will label the outliers in our box plot. By specifying the option to mark the individuals row-wise and to mark them with the label that we created, the underscore n attribute scores the number or the indexes of the observations in your dataset. So we store it under the ID variable and use it to label our outliers. We can see that number 74 is actually an outlier, as well as all these other observations. They are very much far from the mean price. By running the extremes command, you can view the first 5 and last 5 observations. By specifying an interquartile range, you can control the output that you see. So there is another method of generating variables which you want them to store well-known summary statistics like the standard deviation, minimum and maximum values. And the egen command provides these functions that allow you to do that quickly. You can treat outliers in different ways by using Windsorization, which is just a way of replacing the outliers with the next nearest value. If you specify the cut option, it's going to replace it with the last or the first value, which lies in the 1% or 99th percentile of observations. So if you reduce the interval, it's going to replace or trim the outliers using the values that are within now the top 5% and the last 95%. So you can also replace the outlier with a value greater than the outlier, because Windsorization, and when you specify this percentile, it will replace that value with the value next to it, as well as the 3 next observations above it. So the duplicates command checks whether there are duplicates in your dataset. We can rename variables using the rename command if we don't like the name that they have or they are currently displaying. The context that you might need to rename your variables is when reproducing your study or when sharing it with other colleagues. The record command allows you to change the values of certain variables. In this case, we renamed the gender variable to female and dummified the values so that the value of 1, which denoted male, will be now represented as 0, as the column represents only females. So 0 to represent the value of 1, which previously represented males, and 1 to mark true that it represents females, and it has replaced the value 2, which originally represented the females. By tabulating that, you will see how the distribution is across the two groups, the number of people in the 0 false category, the number of people in the true category, their percentage proportions, as well as their cumulative percentages. You can label a variable using the label variable command, these two together, and then you list the variable you want to label and then put your label between parentheses. In this case, the label that you apply, you are going to just see it over here. It is the equivalent of writing or typing in the label yourself, but using the command window. Remember, we said Stata can be operated using the commands or using the interfaces. So we have defined a label to describe the math variable in our dataset to represent that it's just the 9th grade mathematics scores, and this variable here represents the public or private schools in our dataset. You can also define a list of many labels if you have multiple categories in such a variable. So we define using this command, label define, and then state the name of the label container or the variable containing your new labels. So the first argument is the label you want to change. The second is the name you are changing to. So follow that syntax for an unlimited number of variables you want to define the labels for. And applying these labels to values requires you to call the command label values. And we are labeling the school type value with the new labels we defined, so that instead of 1 and 2 we are going to see our new labels appended accordingly. So the encode command converts the string variables to numeric variables. It won't change how they appear, just how they are interpreted in Stata, because some commands require you to have variables in numeric form before conducting the analysis. Calling browse on these two will show that the newly generated or converted variable, it will mark it in blue to show that it is a numerical variable, and it will show it in red. The program type will be in red to denote that it is still a string. So the tabulate command again just describes the distribution or descriptives of our data. To save a particular data set as a new, maybe you want to save it as a new data set because you've made changes, use the save command and the replace option to overwrite any existing dataset with the same name, and you will find it in your working directory. In my case, if I go to my working directory, I'm going to view that data file hs1 because I had already saved it. So here it is, it went to my working directory. So if you don't want certain variables in your analysis, or you have a data set with too many variables and you want to focus your attention on a specific subset of variables, we can use the drop and keep commands, which are self-explanatory, to either exclude or include desired columns. So we can use them in conjunction with the if qualifiers as well as the operators to further scrutinize the inclusion criteria, so that variables whereby the reading scores are greater than 40, only the variables that have their reading scores greater than 40 will be kept in our dataset. And if you keep only these three values, we only want to keep the measurements on ID, the reading scores, and mathematics scores. So all the columns will be dropped if, or not columns, but the observations, right? The individuals upon whom we measured these particular features. So we want to drop all the individuals whose math score were greater than 30 or their math score were greater than 70. And you can run a summary to view the effects of that drop command. So by listing the kept variables, you can also just view their behavior to see the effect of their commands. So we can also append datasets, which means you just add observations to the bottom of an existing table. Just to put that into context, you might have two datasets on the same variables, and this might arise from maybe you're doing different studies in different geographical locations, but you're within the same company, so you've been dispatched to different geographical locations, and you need to join that data because it's on the same measurements. So you can use the append command to do just that, and it just joins one data set to the bottom of another because they are measuring the same variables. So it will make sense to just append the observations right at the bottom. That may not be the case every time. You might want to merge two datasets, so we can do that using the merge command. And we can merge on a one-to-one scale or one-to-many scale, or also alternatively many-to-one. Now, there are many statistical tests that can be performed in Stata. To mention a few, to get the mean of a variable, use the mean command and list your variable next. So this one gets the mean of the specified variable. The Ttest command performs the Ttest, which checks if there is a difference in means across two groups. In this case, we want to check if, or rather test the hypothesis, there is a difference, if there is a difference in the reading scores across males and females. That's what we mean by checking difference in averages between two groups. The correlation command or core in short, with a double R, gets the correlation coefficient for a variable. You can specify 2 or a list or more than 2 to get a matrix containing the coefficients. And from that you can deduce the relationships between these variables by using the scale of -1 to 1, which is used for making inferences on correlation. Finally, the regress command, it fits an ordinary least squares regression model whereby you specify the dependent variable first, and here we are trying to model the relationship between the writing scores and the independent variables, mathematics scores, and social economic status. How do these independent variables influence the outcome, which is the writing scores? For the continuous variables in Stata, you must specify them by prefixing a C and a period to show that it's a continuous variable, and an I and a period before a categorical variable to show that as well. From the model that we have just ran, we can obtain predictions of our y variable by using the predict command and the pred option as well. So combined together, you will see predicted values for our dependent variable. We can also obtain residuals, which are the differences in the predicted values between the predicted values and the observed values, to see whether they vary so much or whether our model has predicted values that are so far away from our average or observed values. And you can apply a logistic model when the outcome is binary, when we are trying to predict whether it belongs to one category or the other, or our outcome has two categories, true or false. In this case, we are trying to establish whether you can identify a male or a female based on their writing scores and their social economic status. That marks the end of our summary. More to come in the future sessions. I've been your instructor Ignatius, and thank you for watching the summary video.